Illinois Stories is brought to you by the Corporation for Public Broadcasting and by the support of viewers like you. Thank you.
Hello, welcome to Illinois Stories. I'm Mark McDonald in Keokuk, Iowa, where Hamilton resident John Kammerer builds his guitars. He's been building them here for 12 years, and it came to my attention when our photographer Randy Phillips saw his guitars in a Quincy music store. And when he saw that they were built in Keokuk, Iowa, I said, we've got to meet this guy. Turns out he is an Illinois resident from Hamilton, Illinois. So John, it's interesting, you've been building guitars in this space for 12 years. And you started building guitars thinking about guitars as a student at SIU, and you were, I think, in industrial engineering. And man, this was a perfect project, wasn't it? Because you loved music and you loved guitars. And for 12 years you've been building them and selling them.
Yes, I have.
It's great.
Yeah, this started out when I was in design school down in Carbondale, and it was a senior thesis project. And it was, you had the choice, or you were told to pick an area of industry you'd like to get into and make a product that improved upon something in that industry. So I thought it would be great to do guitars. And in researching, I was trying to figure out something I could work on, and so I came up with acoustic guitars, where I saw in one of the books on construction of them that said up to 2/3 of the sound waves canceled out due to standing wave cancellation, which is where sound wave bounces into a sharp corner, bounces right back on itself and cancels out. So I thought, well, what if we made a guitar that got around that? And so we're thinking about it, and I was thinking about it, and all my friends in design were all on their thesis projects too, so we'd all brainstorm our projects together. And so then talking one night, came up with the idea of using a parabolic curve to basically be the shape of the guitar. And that's kind of like using a satellite dish or the parabolic microphones where you can direct the sound. So that's one phase of it. The other thing I wanted to work on was alternative materials. With wood being a scarce resource and all of that, what if you did different stuff? So the other thing with it too was being a parabolic curve, I didn't really see a way to make wood in that shape. So I started off with...
these are prototypes.
These
you started off with all kinds of stuff, didn't you?
All this is thesis project work. And so what we started off with, the first thing I did was I had a rough idea of the shape I wanted, which is rounded top, rounded back.
Is that what we're looking at here?
That's what we're looking at here. That's what we're looking at. And what we started with was these blue ones. I made a bunch of sketch models that were basically rough shapes of guitars, different thicknesses, different curves, and I'd take them back to people that I knew play guitar, and I had a lot of friends that played guitar, and just said, hey, what do you think of this shape? And what do you think of this shape? And so we kind of came up with a couple of shapes that everybody liked. And so from that point, what we did was you needed to make molds of these shapes. And so I started off with taking some of the sketch models, which is what we had here, and using a heavier density foam, and I shaped it down and tried to get it as a perfect of a shape as possible as far as finish, and then we'd make molds of it out of plaster, and then we'd laminate it in fiberglass. And so we tried a couple fiberglass shells. This is one version of a deeper back, and we tried several different shapes. And then also with it, I would take them over to the ceramic studio, because I was an art major also, and we tried making a couple of ceramic versions of
This thing weighs a lot.
Yeah, and for various reasons, I decided against ceramics, because part of it is it was just hard to get it to hold shape when being fired, and then the other was the weight on it.
And this is ceramic too, isn't it?
This one's stoneware.
Yeah, stoneware.
And then the other one's porcelain.
And of course that would weigh way too much to handle. And you see, it did sag.
And that was part of the firing process, which at that point in time, my expertise on ceramics wasn't at a level where I could get these to work at a functional level. So that was basically, this idea was basically discarded after these first two prototypes were made.
Speaking of prototypes, all of these up here, now these look like finished, perfect guitars. Of course they're not. That's why they're on this side of the room, right?
Yes, it is.
More experimentation.
It's more experimentation. We started off with, like I said, after we had this done, this was the actual finished one from the thesis project. And we made the jump from this to those. When I graduated science school, I went out to California, and I was working out there, and I was showing this to one of my buddies in the shop. And I'm working as a CNC machinist, where we basically take computer files of drawings of a part, and we machine it out. And he's like, well, you could make this on the mills out of wood. And it's like, yeah, we could. And so I started making them out of wood. And the first one I machined is actually this one right here.
Let's take a look over here.
And this was the first one I did. And
can I pick this up?
You can pick that up.
Okay, I want to show the front and the back of it. That's the shape you wanted.
And that was the shape I wanted.
That's the same shape that you were talking about, that parabolic shape.
And by computer drafting it, it was actually able to be machined in exactly the shape I wanted. No deviations on it. I mean, that's the beauty of computer drafting. You get exactly what you want to do if you're good at it. And so that was the first one. And then I wanted to experiment with different methods of making them. And so that's where some of these came in, was they're just different woods, different shapes. And some of them, like I said, they're nice guitars. This one here and this one here and a couple others are soft maple. And the problem with soft maple, it makes a really pretty acoustic guitar, but it's not quite strong enough. You have multiple types of maple trees. Hard maple's one. All the rest are all considered soft maple. Some of them work, some of them don't. And so I don't really know what I'm getting when I'm buying soft maple. And so it was just too hard to say, well, this one might work, this one might not work. So I quit making soft maple guitars. I still had several in progress, which is what those are, is they could be strung up. They probably would work, but I just don't want to take that chance. So they're basically here on display.
These over here are all success stories. They've all worked in one way or another. This is, now somebody's probably never seen a guitar like this.
I don't think there's anything like that.
Is this fiberglass?
That is cast acrylic.
Cast acrylic.
It's a block of cast acrylic machined out and then polished up. And then one of our patent, actually, I have 3 patents on guitar construction. And one of the patents actually covers the mechanics of making a guitar out of parabolic curves and all that, but also covers methods of construction. So even this guitar injection molded, which would be the way to make it, is also covered under the patent.
Interesting. Okay, now, there's one other thing I want to point out before we get into this production part of it. You do very, very interesting things that I have never seen anybody else do, and it's your inlay work. Now, this may look like this is a painted top. It's not. Those are all separate pieces of wood inlaid. Isn't that right?
Yes, it is. It's actually, it's not even a total inlay. This here is solid blocks of wood. If you look at the end of the guitar, you can see where the seam line is from the back half of the guitar to the top half of the guitar, and the whole top half of the guitar is this piece of wood, and they're all cut out, and this is like a huge jigsaw puzzle. And this one here is actually a real pain to do. I've got this on several guitars. I've got camouflage, and I did the flames over here.
This one here.
And I've done flags, American flags, and
we're going to see that flag.
Okay.
We are, yeah.
And so anyway, this one here is unique in the fact that I have to have help gluing it up because it's so complex. The glue dries faster than I can slap it together. So one of my buddies has to help me glue this up to make this guitar.
Actually, cutting the pieces is easier than gluing it.
Yes, it is.
Because the computer program tells the mill how to cut it, but then you have to hand
every one of these individual pieces is programmed on the milling machine, and it cuts it out, and then we glue them together.
Okay. I'll tell you what I'd like to do next. I'd like to hear one of your guitars, and one of your friends is here to play it for us. So we're going to hear what these sound like, and then we'll proceed with the process. Okay. Alex Culpepper, you like John's guitars enough to have bought one yourself.
Yeah, absolutely.
And you're a friend of his. And as fortune would have it, you're going to be playing at his wedding.
Yeah, I'm going to play. Yeah, that's
one of his guitars at his wedding. Okay, great.
Absolutely.
Now the guitar that you bought is called a Dreadnought, and it's this size, and it's actually just like this guitar.
It's exactly like that guitar. That is the guitar.
And yours sounds better than this one. This one, I'm told, has some sound issues.
Yeah. Apparently, there's a wood defect in this one.
So what he asked you to do is pick another guitar that you liked.
Yeah.
One of John's guitars. And I'm going to ask you to play something because we can talk all day about musical instruments, but unless you hear them, it doesn't do much for you.
Yeah, I understand, and that's how I made my decision on my guitar. Is what I heard.
You toyed around with his guitars until you found one you really liked, huh?
Yeah.
Okay.
Absolutely.
Well, could we hear what it sounds like?
Yeah, sure.
Terrific. Well, John, this guitar sounds good. And
Yes,
it looks good. It's a handsome piece of work.
Thank you.
What do you know about it? I mean, I
Well-
know you made it, but beyond that.
Well, this guitar actually incorporates our last patent, and we have 3 patents total. And the first 2 are covering the mechanical and visual aspects of the guitars: the arch top, the rounded backs, parabolic curves, methods of construction. And then this guitar specifically, when we were experimenting around, the elongated sound hole is what we have patented on here, because this guitar is an offshoot of this guitar right here, where we took the sound hole and wrapped it around a little further.
Okay.
And what that does is when you're playing this guitar, and I'll show you here, you can feel it for yourself, when you strum it and you feel the top here, you can feel that vibrating?
Oh, yeah.
Now feel over here to the other edge, and it's not vibrating near as much.
Right.
And so what that does is this isolates out the top plate from the rest of the guitar. And traditionally an acoustic guitar functions like a big old bellows, and the more bellows action you get, the more sound you're producing. And that's great when you're unplugged, but when you want to play it plugged in, that also drives your feedback. So this here isolates out the feedback loop. So you have the pickup system right here on the bridge, and this nice piece of wood's vibrating. You're getting on an acoustic guitar, what you want to hear is all the wood tones. And so you're getting the wood tones vibrating, and it's going to the bridge, you're getting that sound, but you're stopping the body from doing the rest of what it would do to normally amplify the sound. And it's like playing an electric guitar as far as feedback is concerned. You can make anything feedback if you try hard enough, but you touch the strings and it stops. So this one here is designed where you get it louder and have less issues with it.
And what kind of wood is this, the top?
It's a maple top with a mahogany back. And it's ebony fretboard with abalone inlays in it.
Now, will you ever make a guitar without this patented sound hole shape?
Yes, I've made several. I mean, this here's just one direction we're going with. Some people want more of a traditional looking guitar, which is why we have the dreadnought models.
That's this one here, right?
This one right here. Or we have like a classical profile where they have the round sound holes and different types of inlay in it. This here's kind of a jazz version, and we're bringing out, and I'm always bringing out newer models. So I'm working on, some of them are combinations. I'll do something with one guitar, like I like this, it's an acoustic, but I'm going to be bringing out a version with an actual electric pickup in it, so it'll be more of like an actual true jazz guitar. And it will still have the same feedback resistant properties, but you'll be able to get a whole different tone out of it than you would with a hollow body guitar that's made of thicker woods, because this here is going to be 1/8 inch thick versus being 3/8 of an inch thick.
I'll tell you what, next, let's look at the process of doing this a little
Sure.
bit, because there's the design process, and then there's the computerized version which you work from. You have your computer and your milling all connected, so that when you have the design that you want, you can tell your mill exactly what to do, and we're going to see that process.
Yes, you will.
Okay.
Yeah, it all starts with an idea. And so as far as my manufacturing today, what we started off with is an idea or a variation of the idea. And so we could take anything out here and say, hey, I want to change an aspect on this guitar. And every guitar you see here has a full computer file in my office. And so what we're going to go over right now is just something that's on every guitar, which is the fretboard. And so what we'll do is we'll go in and I'll show you what the fretboard looks like on the computer, and then we'll go out to the milling machine. I've got one set up to run, and you can see how the process works.
Terrific. John, let's take a look at this guitar first and show me what the fretboard is.
This is the fretboard on the guitar right here. It's this black piece, and this one here is ebony with abalone fret markers, and it's got basically a standard fret in it.
Okay, and the frets are these metal bars that go across.
And that's what you fret your note on.
Okay, and that's how you play your chords, and that's
Yes,
where
sir.
you know where you hold the strings. Okay.
Yeah.
Okay. Now, what we're going to see here now, is how your computer program, you can tell this computer what you want, and then it can tell your milling machine how to cut it.
Yes.
Is that right? Show us how this similar fretboard would operate like that.
Okay, this here is the fretboard of the guitar. It doesn't look like what you see there, but it is identical to what is on that guitar. And so what you have is the red surface here is the actual top of the fretboard here that's going to get machined out. And then these little white lines are where the fret slots will be, and then these little blue lines are the outlines for where the fret marker goes. And so what I will do is you come in with here, and this is already a pre-programmed part, and so I've already got all the stuff here. The first thing it will do is it will cut out the top surface of the guitar, and then it will come back through and we'll cut the edge of the guitar out, and then we'll come through and cut the fret markers in.
Okay.
Now, usually on my guitars, I do the fret slots as a separate program because depending on what fret slot the customer orders, I may have to go in with a different cutter. And so I can cut fretboards without fret slots in them and then put them back on my fixture and cut the slots in later.
And then, okay.
And so what we'll have here is basically what this will look like in an actual computer rendering of how it cuts is this right here. Okay. And then that is it cutting it out, profiling it, and putting it in the fret markers.
And you've got one milling machine that'll do all that?
I've got one milling machine that'll do all that. It has 20 different cutters, and you can put whatever size cutters you want in it. And I basically run from my small cutters for doing the fret slots are 23 and 28 thousandths of an inch, which are very small cutters, and it goes up to about a 2-inch cutter. And I've got cutters every size in between. In the computer, when you're wanting to cut something out, you can go in there and pick this. Let's say you want to do that. And you can go in here, and here's your options of cutters that I have loaded up for my milling machine. And that's how you go through and do it.
Well, let's go see those cutters. Let's go see them go to work, huh?
Okay.
Right. Okay, John, now I'm holding a fretboard. This is pre-cut, and this is the length that they all are, I guess. And what this is going to do, we're going to show the audience how you have one set in there, and it's going to be cut, how it follows the directions from the computer model we just saw.
Right. Good. Okay. Well, that computer model, it's fed out to the computer over here. And so what we're going to do first, these have already been cut on the underside, and it's flipped over on a fixture to cut the outside of it now. And so what I want to check, I've got my numbers on here. They're kind of rubbed off over time, but it's got my offset, which is what tells the machine this is where this is at.
Okay.
So the machine knows where it's at. So I just come in here and check, and sure enough, my offsets are all good.
Okay.
So we're on the same, my machine's in touch with where the fixture is, and so now I want to set the machine up to run them apart. So I have the computer over here, which all this is just basically file storage. And I've got a file that I'm going to run. And it will send code over to the computer. And so you can see the code that's came in here.
It's choosing the size cutter now, isn't it?
Yes, it is. And so now what it's going to do is put the finish cut on there. And see, it's got an upward flute cutter in it right now. If it had a downward flute cutter, it wouldn't even have that burr around the edge. It'd cut that much cleaner. It'll all sand off in the end, so.
Okay, John, we were seeing the fretboard being cut. Now we're looking at the finished product here. And amazingly, that machine, you can set it to go ahead and cut the neck.
Yes.
And cut the body of the guitar, which is what we're using here. And then after a considerable amount of work on your part on sanding and buffing and painting and all that stuff, you actually have the pieces to put together.
Yes, I do. This guitar here, it's one we're in process right now. It's basically on the next to last step of production. It needs wet sanded and buffed out. That's why the paint's a little rough right there, but that'll get sanded down to...
It's a beautiful coat of paint.
It'll get...
Or lacquer, I guess.
It's lacquer, but it's actually, to me, it's a rough finish, and it's a little rough on the surface, and that will get sanded down absolutely smooth and then buffed out to a high gloss, and it'll look like you're looking under glass. And so anyway, what'll happen is at that point, after it's buffed out, the pickups we put in, the knobs we put in, and then the neck will be mounted to it. And the nice thing with using the computer control milling machine, this whole thing was drawn up as an assembly, and so the same pinholes we used to hold this down to the machine when we cut it, we will now use to put to the neck. And so this will just fasten right in here like this, and then there will be bolts that go in here to hold it down, and there's the finished guitar.
And you make everything except the hardware?
I make everything except the hardware. Everything on this guitar I've made. I bought the tuning machines. This is cast acrylic. I make that. and I buy the fret wire. But and the pickup systems and all that I'll buy. But like I said, all the wood parts on this guitar are made by me.
Yeah, and you told me an interesting fact about how careful you are with the fretwork here. Not every manufacturer does fretwork like you do.
No. There are several ways to make a fretboard, and basically there's one cheap way and then there's two correct ways, if you ask me. And the cheap way is what they call open fret slots, and the frets will come all the way to the end, and the fret's shaped like a T, and you'll actually feel the ends of the frets sticking out here. And then a nicer way to do it is either having a binding on the neck or doing blind fret slots. And what that does is that basically the tang of the frets is undercut here, and you don't have that sticking out, and it gives you a nice smooth finish on the neck. And so either one's a bound neck or a blind fret slot's a good finish. I happen to use the blind fret slots, but some other manufacturers use bound fretboards.
You don't feel that hanging over at
No.
all. Now this is cool. I love this guitar. This is your American flag guitar. I'm not sure if that's what you call it or not. But again, your work, this is not painted on. These are independent pieces of wood, all cut identically so they fit together.
Yes, it is. And this is walnut and cherry and maple. And we go to the milling machine, and it will actually cut out all these stripes. We'll pre-cut the stripes. This here's a stock block of what this is going to turn into. And so we cut out all these stripes. It gets glued up into a block like this, and then it gets put on the milling machine again once it's glued up into the block, and we'll cut this top out.
And what I find fascinating is, I mean, it's hard for me to envision this. It looks more like a butcher block than it does the top of a guitar, but you can actually make these curves at the end, can't you?
Yes.
Your milling machine can make those.
Yep, and it'll match right up.
Look at that. It looks like inlay. It's actually separate pieces of wood.
Yes, it is.
Amazing, amazing. John, when you look at some of your guitars, you notice the inlay work, and you can see how that works here. You've cut the inlay, and you've cut the indentation just perfectly so it fits in. And that's a little piece of walnut there that would be inlaid?
Yes, it is. On this particular guitar top, I was going with the walnut finish on, or walnut inlay, and like I said, it's a repeating pattern, and it would just sit right in there like that. And as part of the customization of the guitar, whoever's buying it can pick whatever color of wood they like. I have wood in every color but blue. I have all sorts of shades of reds, oranges, yellows, greens. And the only thing I haven't found yet is blue wood. I've got purple. You
haven't found a blue wood, but you can make it blue, I'll bet.
I could stain it.
Sure.
But one thing I try doing on all my guitars, I like having just natural wood tones. And it's just kind of nice to see a whole wall full of just natural wood color guitars.
Yeah. I agree with you. I love your camouflage, and I love your American flags, and I love some of the patterns. But just a genuine, beautiful wood tone is hard to beat, isn't it?
Yes, it is.
Yeah. John, thank you. It's been a pleasure. It's been a great being here. Just a reminder, John Kammerer has built 350 or 400 guitars, but he still builds them to suit the customer. You just put in your order, you get what you want. With another Illinois story in Keokuk, Iowa, I'm Mark McDonald. Thanks for watching.
Illinois Stories is brought to you by the Corporation for Public Broadcasting and by the support of viewers like you. Thank you. For a DVD copy of the program you've just seen, send $19.95 to Network Knowledge, P.O. Box 6248, Springfield, Illinois 62708. Be sure to include the program name, subject, and when the program aired. You can also order with your credit card by calling 800-232-3605.